In this video, we're going to start by focusing on some examples where we can solve using our calculator. So mostly of the problems we wanted exact values, and we were able to use our charts of common angles already created to help us solve. So here we're going to use some equations where the values are not common or that we wouldn't know them. We're able to use our calculator. So we're going to start with this example here. We're going to solve tangent x equals 12.8044 to 4 decimal places for 0 is less than equal to x is less than 2 pi. Excuse me. So we're going to start here, and you want to notice first that tangent x is already solved for. So if you have a more complicated equation, you may have to solve for x first, or solve for tangent x first, but here we don't. It's already solved. And we're using our calculator, and what you can do to find this angle is you can use your inverse function. So remember, our inverse function will sort of undo the tangent function here, and it will actually produce the angle for us. So what we're going to do is we're going to take the inverse tangent of 12.8044 and use our calculator, and that will give us our x value. Now, what we do when we're using our calculator, it's a little bit harder to get all the values with just using the periods. Remember when we were doing the chart, we had all the values usually within the first period group. So your calculator won't spit them all out for you. It's a little bit more complicated. Even though it's easy to use the calculator, you have to be careful with the final answers because sometimes you're missing them. So what we usually do is we use our calculator and we use it to find the answer for the first quadrant. And then we apply that to the particular problem, which quadrant the answer should be in. Okay, so let me show you how to do that first. So we're going to find the inverse tangent here. And we always use the positive value. Here it is positive, so it doesn't change anything. So I use my inverse tangent function. Do make sure you're in the right mode. So notice here that our x value is between 0 and 2 pi. So we're in radian mode, which may not be clear if you just see 12.8, right? You may think that's degrees and it's not, it's in radians. So make sure your mode is in radian mode to start with. And then we're going to use our inverse tangent function. And it's 12.8044. And we're just going to go ahead and round to 4 decimal places there. Sorry, problem with using your cell phone as you get text messages. So we're going to go ahead and use, they're coming in again, 4 decimal places. So 1.4929 approximately if I round to 4 places. So this is the angle here of approximately 1.4929 radians, right? So that would be in our first quadrant. And what we want to think about here is our equation that we were originally solving is tangent equals a positive value. So we need to think about where tangent is positive. So our tangent is actually positive in the first quadrant, in the third quadrant. So you can either remember that we've made some charts before about what quadrants each of the functions are positive in, or if you think about tangent, tangent is sine over cosine. So if we're looking at points, it is y over x. So it's going to be positive in the first quadrant when both x and y are positive. And it's also be positive in the third quadrant where they're both negative because those division would cancel that negative out. So it's positive in those quadrants here. So I have the answer for the first quadrant, okay? When we use our calculator, that's the answer that it's spitting out here, is the first quadrant, and I need to figure out the third quadrant answer. So in this case, to figure out the third quadrant answer, you have to think about comparing it to the first. So the first quadrant compared to the third quadrant would be pi units away, right? If you were circling around on your angle. And just thinking about it here. So if let's say here's my angle in the first quadrant, if I want to go into the third quadrant, then this right here is 180 degrees or pi units. So I can get my next value by going in and adding pi to it here. And you do have a pi feature, or you should on your calculator. So I'm just going to go ahead and type 1.4929. I'm going to go ahead and add that pi value, and I get that x is about 4.6345. Now I'm only looking for values between 0 and 2 pi, and tangent is only positive in the first and third quadrants. So these are my only two values here. And they are approximated to 4 decimal places. Now we're going to do the same thing for another example. And we're going to do the same kind of problem here. So one thing you want to notice about cosine, if you think about cosine, so the answer here is negative. So cosine has to do with the x value when we're thinking about our plane. I'm looking at the unit circle instead. And it's negative. So your x value is negative in the second and third quadrants, right on the left part of the graph, excuse me. So cosine is negative in the second and third quadrants. So we're going to use this idea in a little bit. First, I'm going to go ahead and solve this angle. So I'm going to use my inverse cosine. And I'm going to use the positive angle. Now what happens is you could also plug in the negative here if you want to, and it will spit out one of the answers, but it won't give you the other answer. So it's oftentimes just easier to figure out what happens in the first quadrant and then tweak that to figure out what happens in the second and third quadrant instead. So here, I'm going to go ahead and figure out what this value is. And again, we're just going to go ahead and use our calculator. And let's see, I get about 1.1244, rounding to 4 decimal places, excuse me. Okay. And then I go ahead, this is the answer in the first quadrant, but I actually really need the answer in the second and third quadrants there. So you can think about how to figure that out. So let me make a kind of picture here. So again, this is our angle in the first quadrant. Now I need to get it in the second and third. So in the third quadrant, we've already seen that. We can just add pi to it. So for the angle in the third quadrant, I can take my 1.1244 and go ahead and add pi. And I'm going to go ahead and use my calculator there, and you're going to get about 4.2660 when rounding to 4 decimal places. Now to go ahead and get the angle in the second quadrant, what we're going to do instead is we're going to go ahead and take our original x value, and we're going to subtract it. Actually, I wrote it backwards. Subtract it with pi instead. And that will give us the value in the second quadrant. So I'm just going to go ahead and again, you just use your calculator there, do that subtraction, and you get about 2.0172. So those are going to be our two answers here. Again, we were restricted in this case to 0 to 2 pi, so obviously that is going to affect things. Another little side note too here, just kind of for fun, if you actually did plug in the inverse cosine of negative 0.4317 using the original negative value, you do get the one in the second quadrant here. So you do get one of the answers, but then it's very difficult to try to figure out how to get the other answers sometimes. So you can go ahead and, and maybe find one of them that way, but you may need to use that first quadrant reference to find the others too. I'm gonna pause the video. Everybody can see Griffin. He's coming to say hi. Hi, Griff. Oh, yep, he wants a lot of attention. Let's see. All All right, so Griffey's outside for right now, and he was just coming to say hi for us. And we're going to try another example here. This one's a little bit harder. Again, we're going to use our calculator to help us. And it is sine squared minus sine x minus 1 equals 0. It does look like it's a regular quadratic. You have that kind of trinomial idea. So what I would probably do is recommend, again, just making a little substitution here so you can see what it really looks like. And then remember that instead of u, it's really sine x, right? Now, if you try and factor this, it's not going to work. This is one that's not factorable, but you may remember instead that we do have the quadratic formula. So if I'm making these as x's, maybe we should make it x's, make it a little bit easier. Then our quadratic formula is x equals plus or minus negative b. What am I doing? I'm writing backwards today. Plus or minus the square root of b squared minus 4ac all over 2a. Sorry about that. Griffey has me all mixed up now. So negative b, then plus or minus. I don't know why I was writing backwards. Square root of b squared minus 4ac over 2a. And what happens here is your a would be this piece, right? So our a here is 1. Our b here would be -1, and then our c would also be -1 in this case. So I'm going to use the quadratic formula. I'm going to start by solving. I'm going to solve it regular, and then I'm going to remember later on that it's not really x there, it's actually sine x. So we'll make that change later. And let's actually go ahead and plug everything in. So let's see, I have negative and then -1 for b. -1 squared minus 4 times 1 times -1. All over 2 times a, which is 2 times 1. So here I have +1. On the inside, I have 1. My 2 negatives here will cancel, so I end up with 1 plus 4, which is 5, all over 2. And now just don't forget, it wasn't really x in the problem, it was actually a sine x. So I'm going to just change that back over now. And really, it's sine x equal to 1 plus or minus √5 all over 2. So there are 2 values here because plus or minus give you 2 answers. So I'm going to go ahead and split this up. So I have sine x equals 1 plus √5 over 2. And then I also have sine x equals 1 minus √5 all over 2. And you're going to go ahead and use your calculator here to approximate those values. So for the first one, I have 1 plus the square root of 5, square root of 5, and then divided by 2. So I have sine x is about 1.618, we'll use 4 decimal places, 0. And then for the other one, 1 minus the square root of 5, and then divided by 2. So I have sine x equals, again, this is about -0.618, rounding to 4 decimal places there. So now we're almost done. We're going to use our calculator here to finish solving because it's not x equals, it's actually sine x equals. So I'm going to go ahead and use that inverse sine of 1.6180 to actually figure out what my x value is here. And let's see, that is going to be 1.6180. Oh, I did something. See, I did it right. Let's do it again and show you. Oops, let's show you what happens. So you can see here, I keep getting a domain error. And it's like, wait, what am I doing? And then when I looked at it again, I realized, wait a second, there's no solution here. And the reason there's no solution here is because, well, the sine function, the original sine function, is only between -1 and 1. So there is no solution here. I wasn't doing anything wrong. So this is kind of a good hint. Sometimes if you're kind of working too quickly, like I am, you plug it in, you're like, wait, what did I do wrong? And actually, in this case, I didn't do anything wrong. Check your work, make sure there's no mistakes. This is what it was, but it can't happen. That's too big. So there's no solution for this part. Now for this one here, I'm going to go ahead and do something similar. Don't forget though, I am going to use the positive version when I do this. So when I do inverse sine of 0.6180, checking this with my notes as I go through, That looks good. I get about 0.6662. Now, remember, when using your calculator, it doesn't spit out all the answers. And when we have our chart, we usually have all the values listed for a whole period. Your calculator will only give you one. So the easiest thing to do to find all of them is to actually figure out the positive value first, and then figure out which quadrants you need to be in. Now here, notice that sign is negative, right? So sine x is negative, and sine is negative. In the third and fourth quadrant. Now remember, if you think about your sine value, it relates to the y in a point. So y is negative below the axis, so that's why you're in the third and fourth quadrants here. So this answer is for the first quadrant, and I need to go ahead and tweak it to get to the third and fourth quadrants. So for the third quadrant, we've seen quite a few times, what you can just do there is take your value for the first quadrant. You can go ahead and add pi to it. And let's say I've already done this. When you do that on your calculator, you get about 0.38078. And then for the fourth quadrant, what you can go ahead and do there is you can go ahead and subtract with 2 pi. So 2 pi minus 0.6662, and I get about 5.6170. So now we've seen what to do with all the quadrants. So third quadrant, you can add with pi. Fourth quadrant, you could subtract with 2 pi here and get your value that way. So we have two answers. We have the 3 and we have the 5.